Today, I'll talk about something called transmission diffraction grating. Okay, transmission diffraction grating. Transmission diffraction grating, guys, like the concept of the double slit, but except instead of using double slit, we will use several slits. And diffraction grating is a slide with large number of parallel, closely, equally spaced slits. Okay, I will show you this. طبعا same thing here. We have ray box filter to make it monochromatic or coherent. This is what can we observe on the screen. Same thing, guys. Dark region, bright regions. Dark regions, bright regions. Do you see these lines? These lines, guys, that are observed here, this one, 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 and this one. These are the bright regions. These bright regions, guys, is a result of interference between constructive interference between the waves that are diffracted from the diffraction grating. Okay, يعني احنا instead of one or two slits, double slit, we will have several slits. When the light reach these several slits, they will diffract. As a result of this diffraction, they will interfere. They produce spots, bright spots like this, or bright lights, bright lines. These bright lines, as a result of what? Of constructive interference. The spaces between these lines, right, as a result of destructive interference. When a parallel beam of monochromatic light is directed normally at right angles to it at diffraction grating, light is transmitted by the grating in certain direction only. As the order increases, the intensity decreases, as less number of waves may reach this order of interference. طبعا later on we'll discuss that. هلا هون, as what we mentioned before, this is the central one, or the zero order, has the highest intensity because all of the waves reach this point. Okay. Then the intensity start decreasing. يعني بيكون the highest like this had the central intensity, بعدين بيجي عندنا the first order, بعدين the second order, third order, and so on. Okay. This is first order. This is second order. Sorry, this is zero order. Sorry, now we start counting from zero. Zero. First, second, and so on. Oh, here as well, also. Okay, the intensity decreases away from the center. The explanation: the light passes through each slit is diffracted. The diffracted light waves from adjacent slits reinforce each other in certain direction only, which is the bright line that we observe, including the incident light direction, and cancel out in all other directions. And I can see you, I can show you this. طلع معي هون هذا diffraction grating. Here we have parallel rays, a first slit, second slit, third slit, and so on. طبعا we have several of these slits. So we have slit P, slit Q, slit R, slit, no matter what is it, okay? in certain direction, as a result of arrangement of these slits, in certain directions here the waves are diffracted, so as a result of that they will interfere. It's very similar to the interference of light. It's very similar to the interference of light. Okay, it's a result of interference of light. Okay, هلا we have to focus on this equation. يعني هلا احنا عندنا first equation which was used for double slit. If you remember for double slit, x equals lambda d over a. For diffraction grating, we will use this one. D sine theta equals n lambda. How can we, or let me derive this equation. Look here, please, guys. As what we mentioned before, light from adjacent fringes, from adjacent slits will interfere constructively. Otherwise, okay. Otherwise, these adjacent slits, they will interfere destructively. يعني constructive interference is taking place from the light that is diffracted from adjacent slits, right? From adjacent slits. هذا بيعطيني interference أو constructive interference. If the light meet from two slits, or if the light is outgoing from two different slits that they are not adjacent, they will meet destructively. So here, look here, please, guys. If I consider this line, if I consider what? This line. Okay? If I consider this line as what you see, this line this path, طلعوا معي, this path is equivalent to this path. Right? And they are, or they have the same path. Where is the path difference? This part. And the light that is outgoing from the upper slit will move this distance extra than this one. Okay, so the path difference here equals what? This part. Guys, as what we mentioned before, and the path difference between two adjacent slits must be n lambda to make what? Constructive interference. Okay, to make what? Constructive interference. يعني عشان يصير عندنا constructive interference, the path difference must be n lambda. The path difference must be n lambda, as what you mentioned before, guys. Again, the light that is diffracted from these slits interfere constructively if these waves are outgoing from adjacent slits, who interfere destructively as these waves diffract or outgoing from non-adjacent slits. So since they are adjacent, the path difference حيكون n lambda. So I have constructive interference. If I look to this, guys, pay attention though. This is right angle. This is right angle. This is theta. I need this line. From trigonometry, sine theta equals, طلعوا معي from trigonometry sine theta equals this part اللي هو path difference اللي هو n lambda هذا اللاين opposite over ايش hypotenuse right opposite this is the opposite over what, which is d. Any question, guys? So n lambda equals d sine theta. This is the formula that will be used for diffraction grating. Diffraction what? Grating. What is d? Guys, d is the separation between slits. D is the separation between what? Between slits. Theta is the angle of diffraction. This angle will be measured later on, I will show you, between the central line and the order line. I will show you that. Lambda is the wavelength, so n is the order of diffraction. What does this mean? Let me go back here. And we have what? N lambda equals d sine theta. N lambda equals d sine theta. Guys, look here to the order. Let me discuss with you the order first of all. The central is called a zero order. The first bright spot or the first bright line is called first order. From the right side, it's called also first order from the left side. The second bright spot, it's called second order. This one is third order. And so on. I may have 3 orders, 4 orders, 5 orders according to. So this is the order. Right? It's the order of from a center. It's the order of any question about the order, guys? It's the order of the bright spot from the center. As what we mentioned before, it's the separation between the slats. Sine theta, look to this, guys. Please pay attention to this. If I want theta for the first order, this is the theta for the first order. This is theta 1. It's the angle between the first order and the zero order. This is theta 2. It's the angle between zero order and the second order. This is, if I can say, this is theta 3, which is the angle between zero order with third order. Guys, any question about that? There's something called number of slits per meter. And how many slits in 1 meter? This is capital N. This is what? Capital N. If I want, or if we are given this capital N, it's H1 over D, where D, as what we mentioned before, it's the grating spacing or the separation between the slits. Here we have to find also, or we might be asked to find the maximum number of orders produced. And here, how many orders? If you go back here, احنا بدل ما كان عندنا دبل سلت صار عندنا several slits. تمام. المين difference يا جماعه between diffraction grating والدبل slit انه اللايت interfere او اللايت that خلينا نقول او light waves that are outgoing from adjacent slits interfere constructively, واذا كان مثلا من non adjacent slits they interfere destructively. هي اول difference. احنا اتفقنا انه عندنا دبل سلت. الدبل سلت نفس الكونسبت تبع الديفراكشن جريتنج. في عندنا points where the lights interfere constructively و points where the light interfere what destructively. المين difference خليني بس هيك just very quick thing. المين difference انه هون بس اللايت that او light waves that are outgoing or that are diffracted from adjacent slits interfere constructively. If the light اللي from non-adjacent slits they will interfere destructively. بالاخير يطلع معي هاي وهاي الايكويجن اللي we have to use it. هلا راح اوريكم موضوع diffraction grating كثير سهل. المين بوينت هون طلع معي how many orders هون بالسكرين؟ how many orders؟
6.
اوكي هلا هم 3 orders بس هم 6 او 7 ماكسيما. مزبوط هم 7 ماكسيما. كيف يعني 7 ماكسيما؟ تفرجوا معي. هاي ماكسيمم صح؟ وهاي ماكسيمم وهاي ماكسيمم وهاي ماكسيمم وهاي ماكسيمم وهاي ماكسيمم وهاي ماكسيمم. يعني بقدر احكي انه I had 7 bright spots. صح ولا لا؟ بس كاوردر احنا السنتر we did ايش؟ we called it as zero order. بعدين هاي first order, second order, third order. From the other side similarly first order, second order, third order. هون الماكسيمم number of orders observed a day. كم اوردر انا شايف؟ علامه 3 صح؟ طب كم ماكسيما شايف انا؟ 7 صح؟ اتفقنا؟ 7. كيف maximum number of order؟ يعني بعد هذا الاوردر طلع هذا الاوردر تقريبا approximately 90 degree مع السنترال. يعني هذا الاوردر approximately اللي هو اخر اوردر بين معي. يعني بعد هيك ما في اوردرز. يعني انا maximum order that can I observe here هو third order. بعد هيك ما I can't observe any order. approximately وين جاي تقريبا من السنتر؟ قد ايه الانجل هاي؟ 90 right او around 90. is that clear؟ هلا to find the maximum number of orders okay what I have to do I have to طلعوا كيف نعمل the maximum number of orders by the value d over lambda. okay يعني اذا بدي اشوف قديش عندي انا orders ودائما بعمل round down even I got حتى 3.9. Okay. If I want to find maximum number of spots or maxima, how many maxima do we have? I have to multiply 2 times the maximum order, right? Times what? The maximum order. Plus 1. Okay. Any question, guys?
أستاذ.
Read the question, please.
Describe what is meant by diffraction of wave.
حكينا احنا diffraction when the waves meet boundary, obstacle or gap, it will spread out in all directions, forming geometric shadow, right? When the waves meet an obstacle or gap, they diffract, or they spread, sorry, we have to write spread out, forming a geometric shadow. Hemen, diffraction depends on what? Diffraction of the waves. When it can be maximum, when can it can be minimum. Okay. هلا الwaves حكينا when they meet obstacle or a gap. Okay. They will diffract. Sometimes we will have a larger diffraction, or sometimes we will have a smaller diffraction. When can be a larger diffraction? When can be a smaller diffraction? Or this diffraction depends on what? If the distance or if the slit width equivalent للwavelength ماشي يا همان؟ إذا lambda equivalent للwidth
أنا maximum diffraction.
بالضبط. أقل أو أكثر أقل diffraction. Okay. First of all, B. Electromagnetic radiation أعطانا ال frequency directed towards a slit. Determine the wavelength. The wavelength equals what? Speed over frequency. Speed for electromagnetic radiation over the frequency 7.5 times 10 to the power 9. قد ايه بيطلع هذا الويف لينث؟ حدا يحسب لي اياه بسرعه. زاخر زاخر 0.04 meters يعني 4 centimeters. تمام. قديش السلت ويدث؟ صح. less than
أستاذ ما أتوقع راح يصير في diffraction.
ايوه هو less diffraction. ليه؟ لأن السلت ويدث ما بنقول ما في diffraction، بنقول يعني less diffraction لأنه كثير قريب، يعني من 4 مش كثير قريب قصدي، يعني من قريب الفاليوز يعني somehow close. فهون شو بنقول less diffraction. We have to justify this, guys. We have to justify this. And we have less diffraction. Okay. Any question? Monochromatic light is incident normally at diffraction grating. ركزوا بالله معي. with 60 lines per millimeter. يعني هون 60 slits per millimeter. يعني هاي الكابيتال N. هاي capital N. أعطاني 10th order maximum is observed at an angle 90. Determine the spacing between the centers of adjacent lines or adjacent slits. Right, lines on means actually slits. Okay. We do D. هلا to find D, D1 over N, as what we mentioned before. But here, guys, we have to pay attention. Please pay attention to this. It's an important now. We are given that it's a 60 lines or 60 slits per millimeter. طبعا it should be per meter. This becomes like this: 60 over a millimeter, 10 to the power minus 3 meter. And instead of milli, I have to replace it by 10 to the power negative 3. This becomes m minus 1. This is n. Now d equals 1 over n. Z, could you please find the answer? (1.7 times 10 to the power minus 5). Guys, this is the separation between adjacent slits. هلا B, we are asked about ايش? The wavelength. Since this is a diffraction grating, I will use this formula: n lambda equals d sine theta. N is the 10th order. أيوه. Lambda, we are asked to find it. D, 1.7 times 10 to the power minus 5 sine 90. قد ايه بيطلع لامدا؟ Yes, 0.5 times 10 to the power minus 6 meters. This is the wave length. Guys, here we might be asked also additional one. بدنا maximum number of orders. Pay attention to this. We are asked about the maximum number of orders. Maximum number. هلا maximum number of orders, I can find it by divide n max equals d over lambda. D over lambda. I divided here d by lambda. ليش طلع 0.5؟ طلع معنا هون 2.5. Is that right? I calculated it in the previous class, I think. Anyway, and it's just a matter of calculation. Guys, if I divide d over lambda like this, I will get what? Around 68. I have to round it down. Yani even I got 68.9, I have to consider it as 68. Addition to maxima. How many? What is the number of maxima? يعني كم maxima راح أشوف على السكرين؟ As what we mentioned before, guys, the number of maxima, it's easy. يعني it's an easy stuff. It's not equals 2 times the n max plus 1, 2 times 68 plus 1. Okay, clear? Let me do this question. Hamza, could you please read the question?
16.
Yes, please.
Yellow
light.
light of wavelength 4 times 10 to the power negative 7 meter is incident normally at diffraction grating with 100 lines per millimeter. calculate the maximum number of orders that can be observed.
انت قرأت السؤال اللي تحت. لا انا بدي هذا. اوكي سوري مش شايف انا. anyway مش مشكلة انا بدي this one. sorry. Okay no problem. لا yellow light of wavelength we are given wavelength. تمام this is lambda. Look to this guys. Again pay attention guys here. Normally a diffraction grating with 300 lines per millimeter is incident. Normally a diffraction grating 300 lines per what? Per millimeter. Okay. Calculate the angle between first order and second order. To find this, guys, I have to find the angle for the first order and angle for what? For the second order. First of all, I have to find D. D equals 1 over N. So N equals 300 millimeter per millimeter. Again, guys, in millimeter, I have to replace it with 10 to the power negative 3. So this becomes 300 times 10 to the power 3 n minus 1. Substitute here instead of n, 1 over 300 times 10 to the power 3, I will get this value. So D equals 1 over 3 times 10 to the power minus 5. Here, guys, I will find the angle for the first order, or I will find the angle for what? For the second order. Substitute, direct substitution. 1, wavelength is given, D found, I found theta, which is 9.6. This is theta 1. Here, same thing. I have to find, look what is the difference, guys. Here, I substituted instead of n, instead of 1, I substituted here 2. 2 times 5.5 times 10 to the power negative 7 equals 3.3 times 10 to the power negative 6, which is the wavelength, times sine theta 2, which is 19.5. So delta theta equals the difference between them. Last one, guys, today. خلاص, I'll stop here. Blue light, wavelength, incident normally at the diffraction grating with 100 lines per millimeter. This is N, guys. Don't forget, this is N capital. Here, we have to distinguish, guys, that we have N capital and N what? Small. N capital and N small. D over lambda. D, we have to find it. How we will find D? D, guys, is 1 over N. D is 1 over N again. Or N, we are given 100 lines per millimeter, which is 100 over 10 to the power minus 3 meter. This becomes what? 100 times 10 to the power 3 meter minus 1. In other words, N equals 1 times 10 to the power 5 m minus 1. If I want D, D 1 over, which is this is D. Now, if you divide to find N max, you have to divide D by lambda. If you divide D by lambda, you will get to 22.2. Always we have to round down, guys. Always we have to round down. If I want to find the maximum number of maxima, يعني كم maxima راح أشوف؟ حكينا هذا 2 في N max plus 1. So 2 times 22 plus 1, we have as 45 maximum. We will complete this part next time.
Now here, guys, we have a light ray box filter. Okay, this is called diffraction grating. Diffraction grating means, guys, material that has several slits. When the light reaches the diffraction grating, and this light reaching the diffraction grating, it will diffract. Diffract means spreading out in all directions. Now, the waves that are diffracted from adjacent slits, they interfere constructively, right? So they will produce maxima, right? They will produce what? Maxima. The waves that are diffracted from non-adjacent slits, they diffract destructively and produce what? A minima. If you remember, this is a maxima. This is a maxima. This is a maxima. Maxima, 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 maxima. The waves interfere constructively. Between these maxima, there are minima, where the waves interfere what? Destructively. Constructive interference means that the crest of the first wave meet with the crest of the second wave, resulting what? Larger amplitude wave. So this is why it's called maxima. This is constructive interference. Destructive interference, crest meets with a trough. This is called antiphase. So this will produce zero result or zero displacement. If I can use numbers, rough numbers, let's say this is displacement +3, this is +3 also, positive. So this is a +6. Here +3, -3. So the result is 0. This is destructive. If the amplitude is 0, I will not see anything. Also, let's do this question. Guys, like this, huh? احنا 10 to the power -3. يعني roughly speaking, I can say no, and I want to bring them to the numerator, صح ولا لا؟
Yes.
طيب ده تصير negative, ده تصير positive, والميتر ده تصير -1. Look to this question, guys. Read it, please.
نكتب هذا صح؟
طيب هلا قبل ما تكتب لا خليني بس we have to answer بس and I want you to read the question in order to figure out how we will answer this. هلا عندنا diffraction grating mounted an instrument that can measure angle within at the 0.1 second, 0.1 degree, sorry. Can this instrument used to determine the individual wavelength of spectral lines of wavelengths? And in other words, guys, I want to measure the difference between their angular position. The difference between their angular what? Position. For the same order. يعني I may select the first order or second order or third order. I want to check if this angular position or the difference between the angular position for the same order can be measured using this instrument. Okay, now, first of all, guys, I have to find D, where D equals 1 over N. N, it's given as 40 per millimeter, يعني N equals 40 per millimeter, which can be manipulated as 40 divided by 10 to the power minus 3 meters. Then it becomes 40 times 10 to the power 3 meter minus 1. Substitute here, you will get D. I think D will be 2.5 times 10 to the power minus 5 meters. Look what I will do, or look what I did here, guys. I found, first of all, for the same order, you will first order. I may use a second or third, no matter. I found the angular position, yani I find theta. Look to the substitution, 1 times wavelength. I selected the first wavelength, which is 589 nanometers, equals D times sine theta 1. I found theta 1, which is 1.351. I used the same thing, but now for lambda what? 589 nanometer. Okay. So here I did the same thing. I found theta 2. Here, guys, I found the difference between them. The difference between these readings is 0.001, which is less than 0.1. So we cannot use this instrument to find the difference. Let me give you example, guys. In our ruler, the smallest division, in order to figure out that, the smallest division in our ruler is what? 1 or 0.1 centimeters, huh? Guys, if I have two lengths like this, using a ruler, can I see any difference? Using a ruler. شو رأيك إذن؟
لا.
Definitely. ليه؟ لأنه أنا يعني أنا هدول الاثنين أصلاً I can't measure them using the ruler. يعني I'll be able to measure only the first decimal place. So this change cannot be noticed or cannot be observed. But if the difference, guys, less than the smallest division, the difference cannot be noticed. Okay, Jason? Yes, Dan?
Yes, okay.
Right. Perfect. B.
طب أستاذ بس بتقدر
Yes.
بغير انسترومنت.
طبعا yes، بس هو بقول لك يعني using this instrument اللي هي الانجل the smallest division. هلا أنا مثلا in case of measuring length I can use vernier caliper or micrometer. I will
بس
see the difference.
نانوميتر ما بتقدر مايكرو
لا
كاليبر.
مش نانوميتر، احنا عم نقيس طبعا هي مش نانوميتر، هي مترز.
اوكي.
طبعا nanometers cannot be measured by micrometers. يعني it has a specific way to measure. هلا الوايت light is incident normally at the grating. Estimate the angle between the extreme ends of the spectrum. تمام. For the 10th order maxima. For the 10th order what? Maxima. If I look here, guys, to this, طلعوا معي هون. In each order, يعني هذا first order, صح؟ هذا second order. What is the extreme color? Red. واضح إنه red, right? يعني if I consider this one. So, and I want to measure this angle. طلعوا from this extreme point to this extreme point. This is what we are asked to find. You multiply it by 2. بس
By
احنا ما
2.
بدنا للسكند، بدنا لل10th order. Same thing. This one it's not drawn at 10th order. But we are asked about the 10th order. So I found theta for the 10th order. طبعا wavelength for the red is not given to us. But as what we mentioned before, we have to memorize the wavelengths. And you have to memorize the wavelength of microwave, radio wave, ultraviolet, infrared, visible. طبعا invisible we have to focus on red والviolet only. Red 700 nanometers, والviolet 400 nanometers. You have to memorize this. Now we have to find theta, as what I said. So n lambda equals d sine theta. N is the 10th order. For red, it's 700 times 10 to the power minus 9. D, we found it before. Sine theta, we got theta 16.25. I have to multiply it by 2. Any question? Okay, guys. Let's do this past paper question. Describe the diffraction of monochromatic light as it passes through the diffraction grating. And guys, diffraction means what? When the waves meet obstacle or a gap, right? What will happen to these waves? Spread out. This is the first mark. Forming geometric shadow. This is what? The second mark. Here there's a white light incident normally to the diffraction grating. We will observe an interference pattern, bright, dark, bright, dark, bright, dark, and so on. But here, guys, since this is a white light, since this is a white light, I will observe something, or I will observe the following pattern. The center is white, the first order spectrum, like the question that we did, and the second order is spectrum, third order is spectrum, and so on. Now we are asked that the diffraction pattern formed on the screen has a white light called zero order and colored spectra in other orders, as what we mentioned before. Now the question is, describe how the principle of superposition is used to explain white light at zero order. White light يعني ليه عند الزيرو طلع معنا white وليه عند ال other orders I got a spectrum. I already explained that before. Let me revise this with you so we can understand this question. Okay, guys. In order to understand this, let's consider this example. Okay, here, look to this. Here we have double slit, diffraction grating, whatever, no matter what is it. Okay, white source. When the waves, guys, reach these slits, they will diffract in all directions. As a result of this diffraction, waves will meet at this point, which is the center point. Some waves will meet at A. At the center, we got what? White. At A, we will get ash, or we will get spectra, or spectrum, sorry. تمام؟ شوف ليش. Let's assume this. This is just an assumption, which is not right at all. Let's say that I have two waves that are outgoing. Two waves, guys, that are outgoing from the slits. Here I gave you also in the path difference in the center is 0 definitely دائما. والpath difference and A, يعني difference between this path and this path is 1.5 centimeter at A. Let's consider this. هلا at the center طلع ناخذ السنتر هلا السنتر. ناخذ أول شيء red light. In order, guys, let me remind you by this. In order to check that if the light constructively interfere or destructively interfere, constructively يعني بصير في enhancing الامplitude يعني بصير اللايت more bright. destructively interfere بصير في cancellation يعني ببين dark. I have to measure the path difference على lambda. تمام, we discussed that before, just to remind you. Okay, I divided the path difference over lambda. If I got integer value, so we will have constructive interference, يعني enhancing the color. If I got odd integer over 2, so we will have antiphase, so we have cancellation to this color. Let's try this. For the center, or for the central point, I divided the path difference over lambda for the red. 0 over 3, صح? So the result is 0. If that's right, معناته احنا ايش؟ راح يكون عندنا integer, صح؟ الزيرو هو integer. فمعناته عندنا constructive interference للرد. يعني عندنا enhancing للcolor. Again for blue, I divided the path difference over the wavelength. 0 over 1.5. I got 0 also. So this is integer. So guys, in the center دائما the path difference 0. So when you divide 0 by any wavelength, you will get 0. So all the waves, red, blue, yellow, green, all of them, no matter their wavelength, they will constructively interfere in the center. فكلهم they are enhanced. So when they are enhanced, they will be mixed together, producing a white light. Okay, clear? Jason, is that clear?
Yes.
طيب لو نروح عند A هلا عشان نفهم أكثر. هلا عند A الباث ديفرنس 1.5. أي 1.5. سواء للبلو الباث difference will not change. The thing that may change is ايش؟ the wavelength, صح؟ If I divide the path difference over the wavelength for the red, I will get half. This means that I have what? Odd integer. over 2. As a result of that, the waves meet destructively or interfere destructively. يعني هون بدها تكون cancel out الرد. يعني ما راح اشوف رد بهذا البوزيشن. هون اذا اخذنا البلو 1.5 divided by 1.5, I will get 1, which is integer, so the blue is constructively interfered here. So at A, guys, I will see the blue, but I will not see what? The red. So the center, guys, the path difference is 0. This is why. So if the path difference is 0, no matter the wavelength, all the waves will interfere constructively. So they enhance, or the waves will enhance each other, resulting all the colors. خليني, if I can say that, roughly speaking, if all the colors are appeared at same point, they will mix together and producing what? White. Producing what? White. This is the answer. Okay. And all the wavelengths reach central order with 0 path difference. So all the waves meet in phase, therefore their displacement what? Add up, producing what? Maxima. Here, to obtain مثلا عند الفيرست order زي point A هاي, to obtain maxima, the path difference is what? Equals n lambda. So the path difference depends على مين؟ على lambda here. طبعا هو ال path difference depends على lambda. بس بالسنتر لأنه 0 فهم no matter ال path difference مش راح تفرق. Since blue and red have different lambda, so they have maxima at different positions. Maxima at different positions. زي ما شفنا هلا. عند A شفنا maxima للبلو بس للred it was ايش؟ minimum. But this position we see the blue, but we did not see the red. Clear? Guys, is there any question? Please ask me. Let's complete the question. Now, light wave with wavelength 625 and the second maxima and angle 160. هذا wavelength صح؟ وهذا second order يعني n equals 2, theta equals what? 61. Determine the number of lines per meter. يعني we are asked about capital N. Right? We are asked about what? Capital N. In order to find capital N, guys, I have to find D. Direct substitution to the formula. Second order. Wavelength. 625 times 10 to the power minus 9. D sine 61. If I do this calculation, I will get that the distance is 1,429 nanometers, by the way. I can find N by dividing 1 over D. So the result will be what? 7 times 10 to the power 5 meter to the power minus 1. Okay. هلا calculate the wavelength of another part of the visible spectrum. طبعا هون قصده refer to this question light of wavelength 625. This is visible, guys. Because as what I told you before, we have to memorize that our visible range, this is the visible range, between 400 to 700 nanometers. So we need another wavelength in the visible spectrum, يعني between 400 and 700, that gives maximum for different order, for a different order at the same angle. Pay attention to this, for different order at the same angle. In other words, guys, we have to find wavelength, but at different order. That is in the visible range. So I will start with n equals 1. I will vary the order. I will use this equation, n lambda equals what? D sine theta. 1 is the order. Lambda, I want to find it. D, which is not a change here because I used the same diffraction grating. D is 1429 times 10 to the power minus 9 times sine 61. Why did they use sine 61? Because it's given to us at the same angle. Okay? So if I do this calculation, I will get this. Guys, if you compare this result with the visible range, it's outside the range. Is that clear? Now I will change the order. I will take the third order, not the second order, because the second order is already taken here, okay? With the previous part. Second order, 3 times lambda. Guys, this will not a change, صح? Same separation or same angle. We are asked about this. 3 lambda equals 1250 nanometers. So lambda equals 417 nanometers. Guys, this is within the range. So this could be the answer. Now I have to make double check by taking another order, n equals 4, because I want to check that this is the only answer. Same thing, guys. 4 lambda equals d sine theta. Lambda equals, if I do this calculation, lambda equals 312 nanometers. Oh, this, guys, this wavelength is what? Outside the range. So the answer is 417 nanometers. Okay? Another question here, state what is meant by the diffraction of waves. طبعا we wrote this before. Guys, I think حتى you are familiar with this from the O level. Plane wave fronts are incident on a slit as shown in figure 5.1. Complete to show 4 wave fronts that have emerged from the slit. Guys, if the size of the gap is greater than the wavelength, there will be a little diffraction. This little diffraction will be beyond beyond the edge of the gap. I told you that, roughly speaking, I can draw an angle like this, 17 or 15 from this side. Draw what? This line, and same thing from other side. Draw the dashed line. Here, guys, if you look here, I draw here straight lines. Beyond, طبعا, they are separated as the same as the wavelength, right? As the same as the wavelength. Beyond these lines, I will draw the curved part which shows the diffraction or the spreading. Any question about that? Now here there's a diffraction grating like this. We are given, guys, that the diffraction has 60 lines per millimeter. 650 lines watt per millimeter, which is 650 divided by 10 to the power minus 3 meter. So it's 650 times 10 to the power 3 meter minus 1. I think you are familiar with these things now. Now an image, the zero order is observed for the light that has angle of diffraction equals to 0. Okay, central. أعطاني الويفلينث. ودينا نحدد قديش عنا maximum number of orders. تمام. إذا بدي أطلع maximum number of orders, I have to divide d by lambda. I have to find d first of all by 1 over n, like what I did here. Then I divided n by lambda. طلعوا معي please على الريزلت. الريزلت طلعت كم؟ 2.61. I should round it down. يعني I should not consider it 3. I should consider it what? 2. So the maximum number of orders observed at each side of the zero order is 2. إذا بدي أطلع كم maximum أو maximum number of maxima، بدي أشوف كم maxima عندي. I will use this equation. Maximum number of maxima equals 2 times n max plus 1. So 2 times 2 plus 1. So I will observe 5 maxima. 5 what? Maxima. Guys, slow me down if there is something is not understood. Last thing, which is an easy also, an image in figure 5.2 are viewed starting with zero order and then with increasing order. يعني بلشنا من zero order بعدين سنروح لorder 1, 2, 3 and 4. State how the appearance of the image changes as the order number what increases. طبعا guys, if we increase يعني إذا رحنا من zero order to the first order to the second order, intensity changes but it decreases. When the highest intensity will be at the center, then the first order, then the second order, and so on. Here, same thing. We have the definitions about diffraction, coherence, and superposition. We already defined that before. And here we are asked about to find the maximum number of diffraction orders produced. It's easy. To find n max, I have to divide d by lambda. Well, I have to find d as usual. تمام. d, this is n. صح? 450 per millimeter. So it becomes 450 over 10 to the power negative 3. Meter, I have to change it to 10 to the power negative 3. Milli, sorry. Then I got 450 times 10 to the power 3 negative 1. Then I used this value to find what the separation between fringes. Substitute here, find in max, round it down, it will be a 3. Now here, instead of red light, I used blue light. Yeah. Another student or another experiment is carried out, but with using a blue light. State and explain the effect of diffraction pattern. يعني بنشوف ايش بدي اشوف بالdifraction pattern. I used this equation to interpret that. طلعوا معي شوي. The equation n lambda equals d sine theta. So n equals d sine theta over lambda. Guys, if I use blue, you know that the wavelength of the blue is less than the wavelength of the red. This means that I reduce the wavelength here. What will happen to the number of orders? Increases, right? Clear? If the number of orders increases, guys, I will see more orders are seen at less angles, or at the same angle, at less angular angles. فرجوا معي هون. How many orders here? طلع يزن. How many orders؟ طبعا هذا zero. In this for the blue light. يزن. كم اوردر عندنا هون في البلو؟ 3. طلعوا هاي 1 صح جيسون؟ We starting a central 0 1 2 هاي 3 orders. تمام؟ الريد كم اوردر فيه؟ 2 صح من السنتر. طبعا السنتر راح يكون نفسه لهم الاثنين. مين عنده اكثر انجل، الريد ولا البلو؟ طلعوا هاي البلو، هاي للفيرست اوردر، وهاي الانجل للفيرست اوردر تاع الريد. مين which is greater؟ الريد. فعشان هيك شو كتبت هون؟ طلعوا انه راح يكون عندنا more orders زي ما احنا شايفين هون بالريد بالبلو we have 3 orders, so more orders are seen at less angles, right, for the same order. Is that point clear? Okay, Jason?
Yes, yes.
Okay, guys. We'll stop here. We'll complete next time. And
Okay, guys. I think we stopped here. We did this question the previous time about diffraction grating if I have a white light source. This is a past paper question on November 12/1. Now, let's do another question. Here, state what is meant by diffraction of waves, as what we mentioned before. When the waves meet obstacle or boundary, they will spread out, right, forming geometric shadow. We have to write this. Now here we are given waves, plane waves. Okay, these plane waves, guys, when they meet this boundary, they will diffract in this way. Beyond the edges here in this region, we will have spreading, right? But in this region, the waves, they don't spread, they continue in straight line, because here the size of the gap, it's very obvious that the size of the gap is greater than the wavelength. When we are asked about 4 wavefronts, the other important thing, guys, that the wavelength here should be kept the same. Now, monochromatic light is incident normally on the diffraction grating, having 650 lines per millimeters. If you remember, this is what? This is capital N, which is 605 millimeter. Okay. Now, an image is observed for light has an angle of diffraction equal to 0, whose 0 order, right? Well, then we are given that for incident ray, or incident wavelength 590 nanometer determine the order of diffracted light that can be observed each side on each side of zero order. And this means that we are asked about the maximum number of orders. Okay, maximum number of orders that can be observed. To find this maximum number, we have to use, or as what I mentioned before here, guys. Look, this is a light, this is a monochromatic light. This is diffraction grating. Here we will have orders. The maximum, guys, number of orders when approximately this is the maximum one that can be observed. This angle, right? Yeah, this is the maximum order. This angle is about 90. And beyond 90, we will not observe any order. So here, maximum number of orders, as what we mentioned before, theta will be 90 degrees. Theta, or angle of diffraction, is 90 degrees. So I will use this equation, d over lambda, if you remember. Now to find d is 1 over n because d is not given. N is given to us as 650 per millimeter, which means 650 as what we did in the previous time over, instead of milli, I have to substitute 10 to the power -3, right? Meter. So this becomes 650 times 10 to the power 3 meter minus 1, because I have to move the denominator to the numerator. Now find d, 1 over 650 times 10 to the power 3. Okay, guys? Who has a calculator now?
1.5.
1.5
Oh,
times 10 to the power.
actually.
Yes. Please play and use the brackets like this in your calculator.
To the power of -6.
-6 meter, okay? So now N max equals 1.5 times 10 to the power -6 over lambda, which is 590 nanometers. Pay attention, guys. -9. So give me the exact number, please.
$2.61.
2.61.
61.
Guys, pay attention now, please. Pay attention. Here, I should not write it 2.61. I should not round it. I should round it down. Always. I have to round it down. So basically here, the maximum number of orders is 2. Always, guys, the answer of N max should be rounded down. Any question about that? Guys, if I want to find maximum number of maxima, and I want to find how many maxima did I see. To find the maximum number of maxima, I should use 2 times N max plus 1. 2, n max is 2 plus 1, so I will observe what? 5 maxima, right? 5 maxima. The images in figure 5.2 are viewed starting with 0 order and then with increasing order. State how the appearance of images changes as the order number increases. طبعا intensity changes, right? Or in another word, what? Decreases. Since the brightest maxima will be observed at the center, then the intensity decreases if we go away from the center. Here we have 3 definitions. We already defined them before. Diffraction, coherence, superposition. Parallel beam of red light of wavelength 630 is incident normally on the diffraction grating, 450 lines per millimeter. Calculate the number of diffraction orders produced. First of all here, let me do this very quick, guys. Pay attention, please, pay attention. N is given, capital N, which is the number of slits per millimeter. I have to convert it to meter as what we see here. I changed milli to 10 to the power minus 3. So I got N in terms of meter. Then D is 1 over N. Substitute now in the formula. طبعا I may substitute here sine 90, or I may use what? D over lambda, or I may use here I substitute here sine 90, which is 1, and it will give us the same thing. D 1 over N ده بيطلع D. طبعا this is not negative, sorry, this is positive. So 2.2 times 10 to the power negative 6 over the wavelength, which is given here. Hey, look to the wavelength, guys. Wavelength here is 630 nanometers. Okay, 630 nanometers. Nano 10 to the power 9. I got N max 3.52. Always I have to what, guys? To round down. Always we have to round it down. So the answer is 3. The red light in B is replaced with a blue light. State and explain the effect on the diffraction pattern. Okay, on the diffraction what? Pattern. Look to this, guys. I'll use this equation, which is the equation for diffraction grating. N lambda equals D sine theta. So N equals D sine theta over lambda. If I replace the red light by the blue light, this means I decrease the wavelength. Okay, this means that I decreased what? The wavelength. What will happen to the number of orders? What will happen to the number of orders? Tahir.
Increase.
Increase. It's clear, right? I did not change D, right? I did not change D. D stays the same because I used the same diffraction grating, but I replaced the source, the red light source, with a blue light source. So for blue, we will observe ايش more orders are seen و less angles between the orders. Why? Guys, pay attention. If I will have for the same space, let's say this is the diffraction grating. This is what the diffraction grating, let's say. The blue will have more orders. Let's say like this. The angular position, guys, or the angular separation between the orders will decrease. Okay, the angular. If I use red, let's say central will be the same, it won't be changed. الred رح يكون عندنا less number of orders. كمان. Okay, again, this is the central, let's say. First, second, third. First, second, third. This is if I have the blue light, we will have more orders. For the red, we will have less orders. فالangular position, right? يعني angular position for red one will be greater than the angular position for the blue one. Is that clear, guys? يعني this angle for first order, let's say, is greater than this angle for the first order, but for the blue. So if I have more orders, they will be diffracted at less angles, right? Or they will have different or less angular position for the same order. Okay, this is the first mark. This is the second mark. This is what? The third mark. Now here, what is meant by diffraction of waves? It's repeated. This is June 10, 21. Here we are given this diffraction grating. We are given a dimensions, right? We are given a dimensions between the first order here and first order here. I will show you how did I deduce that. We are given the distance between the diffraction grating and the screen. A spotlight are observed on the screen placed parallel on the grating. The distance between the grating and the screen is 165. The brightest spot, what does this mean? Brightest spot means the central one. Okay, formed closest to B on each side of P, X, and Y. Guys, since it's the closest to B, معناته X and Y هم ال first order, right? This means that they are the first order, X and Y, because they are the closest bright spots to P, separated by 760, calculate the number of lines per meter on the grading. So here we are asked about N. We are asked about what? N. So we have to find N. Okay, guys. So here I have to start with this equation, N lambda equals D sine theta, because in order to find N, I have to find D, because N capital is 1 over D. Right? N capital is 1 over D. Since we are given the first order, so we substitute 1. Here, wavelength is given. We have to find D. Look how did I find the angle 13. Guys, this is the angle of diffraction. So, since these are the first order, X and Y first order, this is what first order, so they are separated evenly about P. So I can find this distance by dividing 76 over 2. 32, right? Sorry, so 32, 33. Okay, guys. So,
38
38. Okay, 38. So I can find it using trigonometry. Tan inverse theta A is equivalent to tan inverse what? Opposite over adjacent, right? Opposite is 38, adjacent is 165. So I will get theta equals 13. Substitute here. I found D. So N equals 1 over D. N equals 1 over D. Any question, guys? Okay, it's direct substitution. Now the grating in B is now rotated about an axis parallel to the incident laser beam as shown in the figure. Okay, and instead of look to this and look to this, pay attention, guys. And we rotated it by 90 degrees. The lines on the diffraction grating at the diffraction grating were vertical. Now they were horizontal. State what effect, if any, this rotation will have on the position. Hello, guys. The position of the central one اللي هو P stays the same, guys. Does not change. Okay? But the position of X and Y are rotated by 90 degrees as well. Okay? And instead of مثلا high central, high X in this direction, high X horn, Y horn, right? They become in this way. P does not change. This is X. Let's say this is Y. Any question about that? Yani instead of this is the screen, the same screen, but they are what? Rotated 90 degrees. Now, in another experiment using apparatus in B, student noticed that the distance XP and PY as shown in figure 4.1 are not equal suggest a reason for this difference, guys. The reason for this difference that the screen and the diffraction grating are no longer parallel. Yani, in order to have this pattern, or in order to have this, this is the diffraction grating, this is the screen. And the screen might be tilted, or the diffraction grating are no longer parallel, or the beam is not perpendicular كيف راح بفوت بين التيم تبعي هيك. Okay guys, we stopped here again. كان انه in order to observe that the interference pattern or the diffraction orders are evenly spaced about the central one, the diffraction grating and the screen must be parallel to each other, and the light, the incident light, must be perpendicular to the diffraction grating. Okay, and this is an incident one. So here the screen and the diffraction grating are no longer parallel.